Now, it's just important to get clear that the only thing that has changed so far is we've introduced a second way of naming an angle. In terms of trig, the sine, cos and tan of the angle hasn't changed. That still stayed the same. That is stored on your calculator. So if you have your angle in degrees, you know how to find sine, cos and tan of that. If the angle, however, is given in radians, you can also use your calculator to find the sine of that angle, cos or tan of the angle. However, to do that, you must have your calculator set to radians. Now, I know for some of you, this has happened accidentally. The way what you have seen in your calculator screen is a little RAD as written here, in the top of your screen instead of your DEG. And in the past, this has been a real problem because all your trigonometry calculations have been incorrect. They've been incorrect because you've been putting in degree numbers and the calculator's been operating in radians. So now if we will have the option of putting an angle size in using radians, and we may want to calculate the sine of that angle in radians. However, we will have to make sure that the calculator is set to read the number that you put in radians, and the way to set it is to access the DRG button. So on most calculators, it simply looks like this: capital D for degrees, R for radians, G, which we don't use. And this is actually the button that you've pressed when you've accidentally been in radians. You've pressed that. You would have seen a little GRAD come up in your screen. Press it again and you saw DEG come up in your screen, your calculator screen. So that's what you're going to want now to be able to use your calculator to find the sine, cos or tan in radian measure. Now, that becomes really important if we are solving a trig equation and we're asked to give the answer in radians. Give your answer in radians. So, normally, for example, to solve a trig equation, for example, if we were told that cos of theta was root 3 on 2, you know that you could use your calculator to find theta by taking cos inverse of root 3 on 2. Your calculator will tell you 30 degrees, and this is a rather specific one because it's actually an exact angle, isn't it? 30 degrees or pi on 6. For this one here, for example, if the tan of theta is 0.7 and you are instructed to solve that, you're finding theta, so you'll be taking the tan inverse of 0.7. Yes, you certainly just go tan inverse 0.7. If your calculator is set to degrees, it will give you the angle in degrees that has a tan ratio of 0.7. So this is not a radian, this is the tan ratio. So your calculator would tell you that the angle is 34.99 degrees, and you might check that. If you then change the setting using this DRG button to radians and do tan inverse, remember, theta is tan inverse 0.7, you should get this 0.611, 0.6 of a radian. I will leave that for you to check that you can actually use your calculator correctly. And just a little reminder there that if the questions do indicate that you're to give your answer in radians, please ensure your calculator is set to radians. You should be right to get started on exercise 4A, doing some questions from the beginning of that set. And of course, I will work through some examples with you, as you can see here, and I'll do that in class, that question 6 and question 7, in class with you tomorrow, so that you can ask for any clarification of these concepts while I work through an example with you.